The problem is to multiply a 1 by 1 matrix and a 2 by 2 matrix. Matrix multiplication requires the number of columns in the first matrix to equal the number of rows in the second. Here, the first matrix is 1 by 1 and the second is 2 by 2, so the inner dimensions do not match. If we try to multiply the 2 by 2 matrix by the 1 by 1 matrix, the dimensions still do not align. Multiplication is only defined if the first matrix has 2 columns or the second matrix has 2 rows. If both matrices are 1 by 1, their product is simply the product of their single elements. Therefore, a 1 by 1 matrix and a 2 by 2 matrix cannot be multiplied directly. This is because the inner dimensions must be equal for matrix multiplication to be valid. The 1 by 1 matrix acts like a scalar, but it cannot multiply a 2 by 2 matrix as a matrix product. To multiply a 2 by 2 matrix by a matrix, the second matrix must have 2 rows or columns accordingly. If you want to multiply a scalar by a matrix, treat the scalar as a number multiplying each element. In summary, direct multiplication of a 1 by 1 matrix and a 2 by 2 matrix is not defined in matrix multiplication rules. First, compare the dimensions of the 1 by 1 matrix and the 2 by 2 matrix. For the first order, the inside dimensions are 1 and 2. Since they do not match, this product is not defined. Reversing the order still leaves inside dimensions 2 and 1. Therefore, 1 by 1 and 2 by 2 matrices cannot be multiplied directly.